Hello guys and welcome in this new lecture. We are going to talk about the devices and equipments used to protect motors. And what we use is overcurrents or overloads or a device which is overcurrent/load. This is what an overload/current looks like. You connect the three phases to the input, you take the three phases from the output and you directly connect it to the three-phase motor. It's like a circuit breaker, but this one is just designed for motors. You have a knob on the left which is used to adjust the rated current. Though they have an advantage over circuit breakers that their response is a little bit faster than those. So if you adjust your rated current to 10 and 11 amps passes through it, and this 11 amps lasted for 3 or 4 seconds, it will cut off the power and trip immediately. So they are more sensitive than circuit breakers. And you might ask, is this fast response due to a magnetic or thermal characteristics? Well, here it is due to the thermal characteristics, and the thermal characteristics that are sensitive in this case. However, this one also has magnetic protection, and as the circuit breaker, it's rated at in between 6 and 10 times the rated current you adjusted. So now we can link what's written on this title with what we learned before. Overcurrent is actually nothing but the magnetic protection, and overload is nothing but the thermal characteristic protection. So there are two faces for the same coin. And the only difference here is a little bit faster response in terms of thermal characteristic than the circuit breakers. Now let's take an example and try to choose a protection for this motor. The rating is 2.2 kilowatts and it's a three-phase, and we'll assume that it's running on 380 volt AC. First, we need to calculate the current consumption of this motor, and here we're going to assume that the power factor for this motor is 0.8. And from the formula we learned before, we get 4.18 amps. Now we can simply choose an overload/current by choosing one with rating in between this range. So since they are adjustable, we can buy an overload/current in between 4 and 6 amps, and we then just adjust it to 4.18. Because we don't want motors to draw more current than their nominal current. Otherwise, the windings of these motors will burn out. And because of the thermal characteristics, we have accounted for the inrush current because the thermal characteristic, as we mentioned, would take around 4 or 3 or 5 seconds to take an action, which is enough time for the inrush current to pass. So we need to adjust it exactly at the motor rated current.